In this episode, we are going to try our hands on this engineering problem. So let's start the problem right away. We have this question. Three cables are connected at A. So three cables, this cable, and that they are all connected at point A, where the forces P and Q are applied as shown. So at the point A2, we have force Q and force P. Knowing that Q is equal to 0, the force Q is 0. So more or less like it does not produce any effect here. Find the value of P for which the tension in cable AD is 305 newtons. Are we okay? So here we have some forces we have to resolve. This is 3D approach. Are we okay? The 3D approach. So straight away, let's see how best we can try our hands on this. Let's write down some parameters given. We know that the force or the tension in cable AD, let's represent it by tension in AD, and that is equal to 305 newtons. Are we okay? We have another cable which is cable AC. So can we also write tension in cable AC? We don't know for that. What about the other cable, tension in cable that's AB? We also don't know the magnitude of the tension. Are we okay? We have force Q equal to 0, but we don't know the value for force P. So three unknowns over here, and we are to determine tension in the other groups and also find the value of this P. Are we good? So since they are 3D, we can start with one of the groups and resolve it into 8 vector components. So let me start with cable AC. Cable AC. So from cable AC, we know that our tension in AC, that's the vector, is going to be TAC multiply lambda AC. And we know that this lambda is equal to the direction of the force on its magnitude. Are we okay? On the magnitude. So we are going to do it straightforward. TAC, we don't know, so I'll write TAC, and lambda is going to be the direction from A to the point C, because this vector is saying the tension is from A to C, looking at the direction of the arrow. So I'll start from A. A is on the X line. This point, it is coinciding or it is on the X line. So to move to C, first I have to move a certain 960 millimeters to the point O, which is against the axis because we are moving in this direction and it is against the axis. So that's going to be a negative 960 for I, that is on the X. So once I get here, I have to go up by a certain amount before I can get here. Are we okay? And now let's try and see. Even from this point is showing us that before you can even get to the x-axis, you have to move down by a dimension 250. Move down by a dimension 250. And this movement is on the y-axis. Before you get to C, first you have to come down to the x-axis, which is the y movement, and that is also against the direction of the y, so it is negative movement, negative 240 on the j. Once you get here, you move also a distance 320, also against the original axis, and that is going to be negative 380 k. Now everything on the square root of negative 960 square plus negative 240 square plus negative 380 square. So this covers everything here in the bracket. So this is for the lambda AC. Now we can reduce this to tension in AC vector is going to be TAC multiplying. We can punch everything under the square root here, and that is going to give us a simple value as 1040. So this is going to be the same as negative 960 I on 1040 minus 240J on the same thing. This is also negative 380K on 140. Are we good? So this is for the TAC. So this is the equation 1. We've established the relationship for the vector tension. Are we good? So let's consider another cable. We can also consider cable AB, from cable AB. So cable AB. We will also do the same thing. That is going to be TAB, the vector 1, that is TAB lambda AB. And that is going to be equal to, we don't know the value for TAB, so we are going to write TAB multiplying the lambda. Before you get to B, you have to also come down a certain negative because it is against the axis. Come down to the x-axis, move on it, and when you move on it, that is a negative 960I. Coming down, that is a negative 240J. Once you get to the origin, you have to move in the direction of the axis. So this is going to be positive because you are moving in the direction of the axis, and that is going to be plus 380K. Everything on the square root of 960 square plus negative 240 square plus 380 square, this way for the lambda B. So you take your calculator, you punch everything under the square root, and you are going to get TAB, that is going to be tension in AB multiplying. When you punch everything here, you're going to get 1060. So this is going to be negative 960I on 1060 minus 240J on 1060 plus 380K on 1060 as our equation 2. This is for cable AB. Now we can consider the last cable, which is cable A to D. So from cable AD, we can also make analysis here. Now, the same approach, tension in cable AD is equal to TAD lambda AD. And this is going to be equal to, now, do we know the value for tension in AD? Yes, that is 350, 305 Newton. So that is going to be 305 multiplying the lambda That's the movement. So to get to D, I'll start here. First, I'll come down again against the y-axis, move in the negative direction of the x. So on the x, that's going to be a negative 900 again and 60i minus this movement. So now pay attention to the y. This from here, the distance from here to D, the vertical distance. If you don't know right away, you can move from the point down to the x, which is negative 240. You come this negative 9, you have to move up again. And this up movement is 900 and what? 60. So when you subtract this downwards movement from it, meaning the distance between this and that, the vertical, is going to be what? 720. Because moving up is positive 960 and moving down is negative 240, you are going to get 720 for the J. That is positive. So straight away you can bring your plus 720. That's for the J. And when you get here, you must move a certain 220 before you can get to D. And that is what? Negative 220k. Everything is on the square root of negative 960i or negative 960 square plus 720 square plus 220 square to get a simplified value. So we can reduce equation 3 or this to an equation 3. Pay attention to the diagram because we are moving to the next page to continue. Are we okay? So there is an assumption that we are going to make. Are we good? Because all the forces meet at A, after resolving all of them, now we have the resolved vector for AD. That's what we are going to get for equation 3. We have that for AB and for AC. And all of them together with P meet at A. So at equilibrium, can we say the summation of all the forces at A will be equal to 0 at equilibrium? Yes. So that will be the assumption we are going to use to find any unknown parameter. So let's continue. Now we continue for the equation, the D. So TAD can be simplified. If you multiply the 305 through, you are going to get, or let's simplify it this way. We have a 305 multiplying this negative 960. When you punch everything under the square root, you are going to get 1220 negative or 720 1220 for the J and negative 220 on 1220 for the K. Are we good? So we can simplify this. TAD vector multiplying this through will give you negative 240i plus 180 for the J and negative 55 for the K. This is equation 3. Are we good? This is equation 3. So now we can also use the assumptions that we made. Are we good? The assumption that we made. So let's try our hands on it. So we saw that K was equal to 0. Yes. And the P force is in the direction of what? The X axis. So P, let's call the force P, but in the direction of what? The I. So that's PI. So at equilibrium, at equilibrium for all the forces at A, then summation of all the forces at A can be equal to 0, meaning the forces are the tension force in AB plus the tension force in AC, the vector plus the tension force in AD plus P plus Q, all at A, will be equal to 0 for this. So now that we know this equation, then we can establish everything, add all the equation and equate them to what? 0. Are we good? So for all the equation, I'm going to group like terms because there's I for each part, there is J for them, and there's K for them. So for the I part, for the I part, I'm going to group them. Since P is in the I direction, so we are going to get P in the I, and from equation 1, we also have a negative 960 on this for the I. Equation 2, we also have, so this is TAC minus equation 2, 960 on this TAB, and for equation 3, the I part is what? Negative 240. I can equate the I part to 0 as my equation 4. Now, for the J part, I can also add all the J parts because first we have from equation 1, the J part is 240 on 1040, and from equation 2, this is TAC. Equation 2, we have 240 on 1060 for TAB, and from equation 3, this is going to be what? For the J part, we are having our positive 180, and I can equate that to 0. Are we good? We can continue from this side. Please pay attention, it's very simple. And for the K part, from equation 1, the K part, we are having a negative 320 on. For the K is 1040, that's TAC. Now plus for equation 2, we have 380 on 1060 TAB, and now from the equation 3, we have negative 55, and I can equate that to 0, calling this equation 1. So this is my equation 5, and this is my equation 6. Are we good? So we have for I part equation 4 and this. So what can we do from here? Now we have some things in common. We can further reduce all of this. You can punch them and reduce them all. Are we good? From equation 6 or from equation 4, which is for the P part, we can reduce this. And since it is equal to 0, can we take all of the negative to one side of the P from equation 4? From equation 4, can we get this equation that P is equal to, when you reduce everything, that'll be 48 on 53 TAB plus 12 on 13 TAC plus 240 as my equation 7. Also from equation 5, we can also reduce equation 5, and this is going to give us, we are going to equate everything to 0. So we will reduce it and we are going to get 12 on 53 TAB plus 3 on 13 TAC minus 180 equal to 0, because from equation 5, I'm going to multiply through by negative, so negative will take care of this, it will take care of this, and it will negate this, equal to 0 as my equation 8. And lastly, from equation 6, we can also reduce it. From equation 6, you can reduce equation 6, that's the k part, to also, as this two you can multiply through by what? A negative to take care of that, or you can also leave it that way. So this, that is going to be 19 on 53 TAB and negative 4 for this, negative 4 on 13 TAC, and we are going to get positive 55. Are we good? We are going to get positive 55 because this negative will affect this and that equal to 0. Equation 9. Now we can do simultaneous equation here because the question is interested in P. If you are doing simultaneous equation between equation 8, so solving equation 8 and 9 simultaneously, you are going to get these values for TAB, meaning TAB is going to, solving this for the two unknowns, that's TAB and TAC, you are going to get your TAB as 446.7 Newton, and your TAC is also going to be 300.7 Newton. Your calculator can help you do that. Now that we have TAB and TAC, the question is asking us for P, the value for P. And from equation 7, we can bring in the values of this and get for P. So our P now is going to be equal to, from this equation, 48 on 53 multiplying this TAB, and that is 446.7 plus 12 on 13 multiplying 341.7 and plus 240 for that. And when you punch everything here, your P force is going to be 960 Newton. Are we good? So this is the solution for the problem we just tackled. Just resolve each of the tension into each component and also resolve the forces. Know that at equilibrium, they all meet at a point and the resultant is going to be 0. Are we okay? So with that idea, you can equate the I part to 0, the J part to 0, and establish some equations out from it. And you can get the answer right. Thank you for watching this episode. Subscribe to the channel.